There we go. So hi, everyone. My name is Abby Currier, and I'm the Community Engagement and Events Coordinator here at the History Center of Olmsted County. We're so excited to see everyone here tonight, and I look forward to learning more this evening about acid rain in Minnesota. Here at the History Center of Olmsted County, we invite people to gather and explore and examine our past as we educate ourselves about the stories of Olmsted County and southeastern Minnesota. We're so excited that you have decided to join us as we take a look at one of these stories. Tonight, we're going to have a presentation from Gregory Pratt on the history of acid rain. After his presentation, we'll have about 15 minutes for questions from the audience, but because it is a smaller group tonight, if Gregory is okay with it, we might just do questions as we go. That's fine, okay. So those of you that are joining us on Zoom, remember that you can put any questions you have in the chat and we'll be able to answer them as we go along. We'll make sure that we keep an eye on that. Also tomorrow, I will be sending out an email with a quick survey along with different resources that we talk about tonight. So make sure to keep an eye on your emails while you're looking for that. We are recording tonight's program, so please keep that in mind. And we're so excited about tonight's talk and hope that you will continue to join us for some of our future events, where we will talk about everything from the Civilian Conservation Corps to Mayowood's historic landscape to immigration and everything in between. These talks are one of the many great benefits to having a membership to the History Center of Olmsted County. And we certainly hope that you will continue to join us for these talks we hope that you'll consider getting a membership to experience even more benefits. Tonight, we are joined by Gregory Pratt, who has a long career of looking at the environment and how humans have impacted it. He worked for the Minnesota Pollution Control Agency and later as a professor at the University of Minnesota in the School of Public Health. He has done extensive research on the history of acid rain and Minnesota's role in the environmental movement to mitigate the effects of acidified lakes and bodies of water.
Thank you, Abby, for inviting me down. And thank you also for arranging the wonderful weather. It's
Hold the mic closer to you.
well, there. So, can I do that? Can I turn the volume? So he's having trouble hearing.
Yep.
So, if I need to
Just take that with you wherever you want to go.
Okay. Can you? And so he's hearing through this or not?
That's strictly for the Zoom.
Okay.
So we don't have any audio reinforcement in here.
I'll just have to speak more loudly.
We'll come out a little bit.
Yeah, okay. So again, thank you for arranging the nice weather. It's been quite cold and wet up back home in Minneapolis. And so it was nice to get some sunshine down here. Yes, my background is I studied at the University of Minnesota. I have 3 degrees from there. And I studied the effects of air pollution on vegetation. But then I did a postdoc looking at the transport of air pollution. This was in 1982 timeframe, and the job market was not very good. And I applied many places, but I ended up at the Minnesota Pollution Control Agency, and I was there for 32 years. And I worked on not only the transport of air pollution, but also the sources, what the concentrations are. We made measurements of air pollution, and then we looked at eventually what the potential health effects of air pollution might be. But the first thing that I worked on at the Pollution Control Agency was acid rain. We developed a standard and a control plan for acid rain, and that's part of what I'm going to talk about here today. So, but first, the story is in the article that I wrote, and so I don't want to just regurgitate that. I'm going to give a little bit of a personal history. So I'm going to start out. Tomorrow is Earth Day, as I'm sure you know, and this harkens back to the first Earth Day in 52 years ago in 1970. I was a high school senior. I arranged with my parents that I should go to the demonstration at the University of Minnesota, and there were demonstrations, tens of millions of people across the country. Then I would go to the demonstration at the university, and then there was a bike ride through downtown Minneapolis. So I I did that back in those days. Now, the first Earth Day came about as a result of the situation at the time back then, and there were a lot of things going on. So you probably have heard of Rachel Carson, who wrote Silent Spring, which was published in 1962. It's oftentimes thought of as one of the starting points of the environmental movement. In 1967, Minnesota was a little bit ahead of the curve and started the Pollution Control Agency. Also at that time, the Cuyahoga River caught fire in Ohio. It had caught fire actually previously, but arguably the biggest fire was in 1969, and that got a lot of attention. So that led up to the first Earth Day and the formation of the Environmental Protection Agency. Also passed at that time were some significant pieces of legislation: the National Environmental Policy Act, the Clean Air Act, the Clean Water Act, and also in Minnesota, the Boundary Waters Canoe Area Wilderness was formed. That was a controversial struggle at that time. There was also a 3 Mile Island in those times. So the 70s were kind of a heady period when a lot of environmental things were happening. Consciousness was raising and people were looking for action on environmental issues. However, in the 1980s, Reagan was elected, and at that began kind of a pullback from some of the environmental regulations. Now in Minnesota, this is a graph of the political situation. So across the bottom, you can see the governors, starting in the 60s with Levander, and then there was Anderson, Wendell Anderson, Rudy Perpich. Then we had Al Quie, followed by Perpich again, and then Arnie Carlson. So that's the governorship changed hands across parties during the 70s and the 80s. In the Senate, that's the dotted lines. You can see that early on, when Levander was governor, the independent Republicans dominated the Minnesota Senate. But during the Anderson Perpich years, the Democrats came to dominate. The House, which are the solid lines, was much more, there was a lot more fluctuation on the House side of things. But despite those differences, despite the party alignments, the legislature came together in 1982 and passed the Acid Deposition Control Act. This was the first piece of legislation in the country that addressed the acid rain issue. So that led to eventually in 1986 the promulgation of the standard. And I'll get into that a little bit more as we go along. But I want to digress on a kind of a personal note. I did my undergraduate degree in the botany department at the University of Minnesota, which has a long and storied history. And some of the important players in that department were Al Gorham, Albert Frankel, and my father, Doug Pratt. So what you see is the only picture I could find of the old botany building. There was also across the street from it was the old zoology building on the East Bank campus of the University of Minnesota. Both of those buildings were raised to make room for medical school buildings, medical science buildings. My dad and Evel at that time taught a course called Biology and the Future of Man. Now, at that time, I was 15 years old and I was, couldn't get a proper job. And so I ended up working in Dad's lab. And I met these guys, Gorham, Frankel, and so on, and many others. Went out in the field with them and so on. And that was my introduction to environmentalism. Dad and Evel actually testified before the legislature on the hearings that led to the development of the Pollution Control Agency, where I later ended up working. So it all kind of comes together. But Dad and Evel taught a course called Biology and the Future of Man. They started teaching. First of all, they didn't get the university would not give them permission to teach this course, so they taught it on their own. But after they taught it for a couple of years, they got permission, and they taught it for many years, looking at topics in the field of biological sciences that related to environmentalism and how it affects humanity. This was a very important guy back in those days, Albert Frankel. He grew up in Nazi Germany. And as a teenager, his uncle arranged for him to escape from Germany and come to the United States. Several of his relatives did not make it out of Nazi Germany and perished. But he became a renowned scientist, and he's most famously known for discovering this process called photosynthetic phosphorylation in bacteria. So it's in this photosynthetic phosphorylation in bacteria occurs in organisms that are anaerobic. So they have to live where there's no oxygen. So they live in marshes and swamps and soggy soils and that sort of thing. Photosynthetic phosphorylation is how organisms, plants, and bacteria capture energy. They store it in this molecule called adenosine triphosphate. And I put the equation up there. Anyway, he became famous for this, and he was a professor at the University of Minnesota, and his office was across the hallway from the laboratory, my dad's laboratory, where I was working. And his office was filled with books, 2 layers thick on both sides. To walk into his office, you had to go sideways. And he sat at a little metal table with his typewriter, with his old-fashioned typewriter, and that was how he worked. Quite a character. But he was a mentor to my dad, to Evel Gorham, and to me, and to many others as well. This is Evel Gorham. He passed away just a few years ago now, and he was not only a family friend and a mentor and a teacher. I took classes from him, but he was also, in his own right, a very important and famous scientist who the headline on his obituary read, "The Father of Acid Rain." Okay, and I have some links. So if you have this PowerPoint presentation, you can click on those links and read more about Evel Gorham. He was born in Halifax, Nova Scotia, and then he went to England to do graduate work, and he ended up doing work in bog ecosystems in the Lake District of England. Okay. He was interested in nutrient cycling in those bogs. And one day he was out doing field work, and I'm going to read this out. He was looking at these bog plants, and he thought, then, as if a light bulb flashed to my head, I suddenly realized that the local hillsides contained their own ion exchangers in the form of sphagnum moss. Next morning, I gathered some moss, brought it back to the lab, burned it, and placed the ash in the Geiger counter. When I switched on the counter, it began chattering so rapidly that I rushed down to my colleague Don Swift's office, shouting, "Don, come quick, something's gone wrong with the machine." He accused me of contaminating the machine, and the counts I was seeing were impossible. So at that point, I began testing all ashes of all sorts of plants, mosses, lichens, ferns, herbs, grasses, etc., and found that mosses and lichens were far higher than others in this radioactivity, radioactive fallout. And this is because mosses and lichens don't have roots in the soil. They derive their mineral supplies from the air. So why was this important? Well, at this time, when Evel Gorham was doing this work in the English Lake District, there was testing of nuclear weapons going on in the atmosphere, many of them in the Pacific. And this is one of the famous images of an atomic test on Bikini Atoll in 1946. And Evel put two and two together. The radiation that he was seeing in the English Lake District was coming from half a world away, traveling through the air and being deposited and finding its way into plants. Then another light bulb went off in his head and he said, okay, reindeer eat mosses and lichens. Sheep eat grass. And he said, okay, reindeer should end up having higher levels of radiation than sheep. And people, the Laplanders and so on that eat reindeer should have high levels as well. Well, it turned out that that was true. People started making measurements and they found that indeed reindeer had high levels of radiation because they were eating these mosses and lichens that got their nutrients from the air. Whereas sheep were eating grass that got its nutrients from the soil. So this was one piece of evidence, one of the strong pieces of evidence that was used to develop the Nuclear Test Ban Treaty of 1963. But it also opened people's eyes to the idea that what happens elsewhere can come around and affect places far away. And that was the beginning of realization that acid rain could have an impact. So I think I advanced one too soon. Gorham then said, okay, we're putting out a lot of air pollution in our industry. Is that finding its way into our lakes and streams and causing problems there? And he thought, yes, it would do. He, by the way, left England and went to Canada, to the Sudbury area. And he and Alan Gordon studied the situation around Sudbury. Sudbury was the location of the INCO, International Nickel Company. And they had been smelting nickel ore there for a long time. What they did originally was cut down the forest, piled up the wood, put the ore on top, set it on fire, and the liquid metal settled down to the bottom into pools. That was how they smelted it. Well, by the time Evel came around, they got a little bit more sophisticated about that. But if you go to Sudbury, it's still a damaged ecosystem. I was there in the 70s, and parts of it were like a moonscape. There were some mosses and so on starting to come back, but for the most part, it was, a destroyed ecosystem. I think now there are small trees starting to come back. As a result of the work that Gorham and Gordon did, INCO built a superstack, a 1,250 foot high smokestack, which was at that time and for many years afterwards, the tallest smokestack in the world. And it's ironic because they built that smokestack to ameliorate the effects of the smelting in the area around Sudbury, but it had the effect of allowing those pollutants to be transported far downwind and have effects elsewhere. Okay, this is another important guy on the scene who also, unfortunately, recently passed away. His name is David Schindler. David Schindler was born in Barnes, Minnesota, and he studied at the University of Minnesota and also the University of North Dakota. But he received a Rhodes Scholarship and went to England to study and became aware of what Evel Gorham had been doing. So after he finished his scholarship in England, he came back to Canada, actually. And he was offered the possibility of helping to start a new study called the Experimental Lakes Area. It's located just a few miles from Lake of the Woods in Ontario. So it's just across the Minnesota border to the north. And so he started doing studies there of several different kinds. And I'll get into some of those were in a moment, but I want to tell you a little bit about David Schindler. If you read his obituaries, they talk about him being a scientific giant, and he indeed was that. There's a BBC story about him. But he was also, he told it like it was. You know, he didn't mince words. He was a very interesting fellow. He was a competitive musher, so he raced dogs. He raised and mushed dogs. I don't believe he ever competed in Iditarod. He may have competed in the bear grease. I'm not sure about that, but he did race competitively. He was a competitive musher. He also, in this experimental lakes area, there are hundreds and hundreds of lakes. There's so many that they're not named, they're numbered. And many of them, the only way to get in is really to fly in. So he did a lot of flying, landing on these lakes and float planes. And one day they had some weather and some engine trouble, and they had to land on a remote lake. And the pilot came down and they landed poorly. The plane flipped over, and so they were stranded there. Neither Schindler nor the pilot were seriously injured in the crash, but Schindler jumped out, and I think there was some distance from shore, and he wanted to swim to shore, and the pilot would not jump out. So Schindler climbed back, and the pilot said, "Well, I can't swim." So Schindler said, "Okay, I will help you to shore." So he did, got them both to shore, and they were rescued. So that's the kind of a guy he was. One of the first studies that they did at the experimental lakes area was to look at the effects of nutrient additions to lakes. So this is Lake 226. They put a plastic curtain across a neck in the lake, and on one side they added phosphate. At that time, phosphate was widely used in detergents. And so they wanted to see if this phosphate was affecting lakes. Well, guess which side the phosphate was added to. And this experiment has been called one of the most significant experiments in the history of limnology. And it led to bans in sulfate in detergents. The next one, well, there were many experiments done in the experimental lakes area. The lakes were considered environmental laboratories where they could be manipulated and changed in some ways to try and see what might happen. Lake 223 was a lake that was selected for looking at acidification problems. And Schindler and Gorham by this time were communicating about what might be the best thing to do. And so Gorham also helped Schindler develop the idea for this study. And what they did was add sulfuric acid to the lake to acidify it. And you can see packages back there of sulfuric acid. They added them to the lake, and then they made measurements of what was going on in the lake. And the most dramatic thing they saw was this. There were a lot of things that they measured that changed, but the fish on top, these are both lake trout. The fish on top was in the acidified lake. The fish on the bottom was in a non-acidified lake. The acidity was not harming the fish directly. What was happening is that the acidification of that lake was killing off the lower organisms in the food chain. And so the trout were starving in the acidified lake. So this also was one of the most important photographs that led to concern about and action on acid rain. To address the issue, many lakes were already acidified, And so what some people started doing was adding lime to lakes to, buffer them. And this happens to be a lake in northern Sweden. I took this picture at, it was a demonstration put on at a conference I was at. They did this at many lakes. They used helicopters, they used boats and so on, and they added lime to the lakes to try and bring the pH up so that the organisms in the lake would not be damaged. At the same time, in addition to effects on lakes and streams, there were effects on forests. And so in the Adirondacks, in the mountains of North Carolina and Virginia and so on, there were forests that were severely damaged. And that was a lot studied by researchers in that area. In Minnesota, in the 1970s, we built a coal burning power plant in Sherburne County called Sherco. It is still to this day the largest power plant in Minnesota, and it burns currently 3 what they call unit trains, 100-car trains of coal per day. And this plant was built specifically to burn Western coal from the Powder River Basin. Previously, the coal burning power plants in Minnesota had been burning coal from the east, from the Appalachians and so on. But at that time, Western coal was ramping up production, and they wanted a market, and the price was right. The sulfur content of Western coal was lower, so they would say, well, this is better than the coal from the east. And so Sherco was built by what was then Northern States Power Company, and they began burning this Western coal. The Sherco power plant was first built as 2 units, Sherco 1 and 2, in the 76, 77 timeframe. And then Sherco 3 was added about 10 years later. It is planned, so the company is no longer Northern States Power, it's Excel. And Excel has said that they want to get out of the business of burning coal. They have already changed 2 power plants, the Highbridge power plant and the Riverside power plant that had burned coal, burning Eastern coal. They converted them to burn natural gas. So they're moving away from coal. And they're also adding a lot of renewable solar and wind. And they want to decommission these Sherco power plants in the not too distant future. So one of the things that we began doing when this concern about acid rain came to the forefront was begin measuring precipitation. And this is a typical sample. There's a bucket on one side when it rains. This bit, I can use the printer. This bit here is a rain sensor. When it senses rain, the top moves over and it collects rain on the other side. So we made measurements and put together maps of what the picture looked like in Minnesota. You can see that there's a gradient with higher sulfate deposition in the southeast corner of the state, and generally on the eastern part of the state, and lower sulfate deposition on the western part of the state. Also looking at the pictures kind of similar with the precipitation, the acidity, the pH of precipitation. On the eastern side of the state, the precipitation was more acidic, the lower pH, and on the western side of the state, the pH was higher and less acidic. We did modeling studies to look at where this came from. These were in 1980 emissions, and you can see the Ohio Valley clearly a lot of emissions. Texas, this map did not age well. This is as good as it gets. Texas also has a lot of emissions from the oil industry on the Gulf Coast. But then taking account of airflow patterns, we get a lot of our precipitation from the Gulf of Mexico. So that southerly airflow brings up air that's been across these southern states. And we, of course, also have northwesterly flow. So this is a map of what contributes the most. We contribute the most to our own sulfate deposition, but Texas contributes a lot, the Dakotas, Manitoba, so on. And surprisingly, Alberta, this was in the tar sands began ramping up. Surprisingly, Alberta contributes quite a bit. This is a pie chart. So Minnesota is the biggest contributor to sulfate deposition in Minnesota, Texas next, Missouri, Iowa, Wisconsin, and so on. So the Pollution Control Agency pulled all that information together and put together a case for rulemaking. And in order to do that, they needed to compile a statement of need and reasonableness. Why are these rules needed and why are they reasonable? This was done in 1985. So this is 3 years after the legislature said that there should be a standard. So based upon that, there was a rulemaking process that went on, and it was quite controversial. There were a lot of interested parties, MPCA, of course, but also other governmental agencies, environmental groups. Canada was involved, and there were hundreds and hundreds of people that came to meetings and wrote letters. On the other hand, the electric utilities, the taconite industry, the coal mining industry, and the Electric Power Research Institute were all opposed to these rules. And of course, they also hired some university scientists. However, the rulemaking procedure went on. There was an administrative law judge, Alan Klein, who heard all the testimony and made a report back, and he basically said that the Pollution Control Agency had done something that was needed and one was reasonable, and that the standard that the Pollution Control Agency proposed should go forward. It's a standard of 11 kilograms of wet sulfite deposition per hectare, and that was considered necessary to protect sensitive resources. Since then, it's become clear that even lower number is really needed. And then, so this on the right is just the biennial report from 1986 about all of that. That was the first rulemaking, the first law addressing acid rain in the United States. And it happened in 1986. 4 years later, the federal government, Congress acted. They revised the Clean Air Act, including Title IV. They added Title IV, which is concerns acid deposition control. And basically, they did not set a standard. What they said is there should be technological means employed to reduce emissions. So it required the utilities who were burning coal and emitting sulfur dioxide to put on control equipment to burn lower sulfur coal. But it also set up a trading system. So one company could reduce more and another company could be above the limits. Anyway, that was passed in the Clean Air Act amendments of 1990. So the federal government eventually took action as well. And what has been the result of that? These are sulfur dioxide emissions. And you can see in this time period that we're talking about, Minnesota emissions dropped dramatically. And then once the federal government acted, national emissions dropped dramatically as well. And out in the real world, what has happened is that those regulations have been effective. So you can see quite a bit higher levels of sulfate deposition in 1985 compared to 20 some years later. And I just want to close talking about a few take-home messages from this. First of all, this whole process was carried forward the legislators came together, they worked together, they passed laws, both at the state and federal level, to address a problem that they agreed was a problem and that they recognized. Okay, today we are faced with an even more dire problem, which is climate change. And as you can see, we now are increasing carbon dioxide levels in the atmosphere very dramatically. And we're beginning to see some very dramatic effects on our planet. So, unfortunately, at the present time, we haven't been able yet to come together to address that problem effectively, as we did do with the acid rain problem. And so some of the key messages are that air pollution and other pollution doesn't stay put. It gets around. And so it crosses jurisdictional boundaries, political boundaries, and what happens over there can affect us over here and vice versa. But if we agree to recognize the problem and take action to address the problem, then we can find solutions. So this was Evel Gorham's, this is from an unpublished manuscript by Evel Gorham, and it was on his on the program at his memorial service. And he says there is reason for hope. It may seem unimaginable that we can learn to manage consciously the entire planetary ecosystem. We should, however, remember that throughout our relatively short history, the unimaginable repeatedly has morphed into the commonplace. So that's all I have to say, but if you have questions or something that you'd like to say or discuss, I'd be happy.
I have a question on my mind forever. Is there anything possible to make coal clean, this clean coal business? Is there a way, is there such a thing as clean coal?
So yeah, that term clean coal has been around for a long time. It came about initially during the acid rain times, and people thought, yes, you can burn coal and capture the sulfur emissions so that it's, you don't have that acidification effect on the environment. However, it's very difficult to remove the carbon dioxide from coal. So burning fossil fuels is really difficult. There are probably much better alternatives to producing our power than trying to do it with coal and removing the carbon dioxide.
So we can remove the sulfate out of coal, but now we've got to still have the CO2 problem.
Exactly. So we're in my opinion, I think we're at the point where we need to think about removing carbon dioxide from the atmosphere. If we go back to this, this is hundreds of thousands of years of record, and we're way above where we were. And so there are technologies that are on the drawing board and in test phases to remove carbon dioxide from the atmosphere. If we want to prevent the worst impacts of climate change, we have to, first of all, stop putting more carbon dioxide into the atmosphere and find ways to take some of it out.
I have a question that probably should have been brought up at the beginning of the presentation, but can you define what acid rain is and like how the rain becomes acidified?
Yes, I think there was something in one of the slides that defined what, obliquely defined what acid rain is. So water in the atmosphere comes into equilibrium with the carbon dioxide concentration of the atmosphere. At that equilibrium, the pH of that water in the atmosphere is about 5.65. So that's considered to be, natural rain. Rain that is more acidic, has a lower pH than that, is acidic. So when you say acid, where on the pH scale does one draw the line and say this is acid and this is not acid? As you move to lower and lower pHs, things become increasingly acidic. And some things at the very extremes are clearly acids, strong acids. Some things in between are weaker acids and so on. But when you get below that 5.65 level for rainfall, it's acidified. Now, as we increase the carbon dioxide concentration of the atmosphere, there's going to be more carbon dioxide in the rain. It's going to be actually a little bit further acidified.
Question in the chat.
Yes.
Is the amount / percentage of toxins in the plants equal to the amount / percentage in the animals that ate them? Probably referencing that earlier study. we were talking
Okay, so yes, is the question is, I think, as I understand it, is if we see the radioactivity in the lichens and mosses and so on, that's going to have a certain concentration. The organisms that eat that, some of them are going to actually concentrate it. So, for example, reindeer that would eat mosses and lichens that have radioactivity in them, that radioactivity is going to be in the form of oftentimes strontium, strontium ions and that sort of thing. Those are going to preferentially go into the bones. And so some things like reindeer can accumulate radioactivity.
So it's actually more concentrated in the animals than it is in the plants.
It can be, yes.
Same process happened like with us if we also ate radioactive plants.
Yes, if we are exposed to radioactivity, it would concentrate in our bones as well.
But could we pick it up from the meats? Like if Iris were to just exclusively eat reindeer, would she pick up radioactivity from it?
If there was radioactivity in the reindeer meat, you were eating reindeer meat, yes, you would get that into your body. The extent to which you would accumulate it depends upon a lot of different factors. It depends upon how much is in the meat. It depends upon what other things you're eating at the same time. So it's really hard to say, but generally speaking, if you're eating something with radioactivity in it, you're going to get that radioactivity in your body as well.
Is the acid,
Who gets the gold star for having the worst atmosphere in the United States? I've been told that the area southeast of the Gary, Indiana complex has a higher incidence of cancer and stuff than many other places out for about 100 miles across northern Indiana. Does that hold out as one of the places where you just soon not live?
Well, I'll start out coming at it from a different angle. We here in Minnesota get a gold star because we have clean air. Despite the pollutant emissions that we have here in the state, and they're not insignificant, we have nice westerly breezes that blow our pollution away. And most of the pollution sources are on the eastern side of the state in the metropolitan area. And so they get blown away. So we get a gold star because we have good air, good wind. There are a number of places in the country that have severe air pollution problems. And it just depends upon what pollutant you're thinking about. But the Gulf Coast of Texas the Gulf Coast of Texas has a lot of petroleum industry, and there's a lot of problems there. There still are a lot of emissions in that the Rust Belt, along the south of the Great Lakes, including Indiana, Ohio, Pennsylvania, and so on. There are still a lot of areas there that have high pollution levels. So yes, there are places that are, where the air is not as healthy as elsewhere. But that being said, it can depend on the very specific location. So within a given state, like for example, in Indiana, the northern part of industrial part of Indiana has worse air than the southern part. The southern part is really rugged and mountainous and rural and undeveloped. And the air there is going to be cleaner than it is in northern Indiana.
Going back to the concentration of radiation, do you see a similar effect with the acidified rain? So does it continue to concentrate up the food chain?
No, not so much. The acidity, has more direct effect on organisms, but the acidity itself does not tend to accumulate within organisms.
You guys did good hanging in there.
I have one more question. Did any of the scientists' careers suffer from disclosing the causes/problems associated with acid rain?
That's an excellent question. Evel Gorham did not. He was well respected and he did not suffer consequences from being outspoken. And on the other hand, David Schindler, as I mentioned, he was prone to speak his mind, and he did get himself into trouble a few times. But as he said, later in his career, he got awards for things he was chastised for, and early in his career, he got reprimanded for some things, and then later got awards for the same thing. But another story about Schindler is that, the Canadians were saying that, that there were some lakes that were affected in Canada, but they didn't. It was a politically touchy situation between the United States and Canada because there were a lot of emissions coming from the United States, and the United States did not want to own up to the fact that they might be damaging Canadian lakes, and the Canadians didn't want to press the matter because it was politically sensitive. Well, Schindler was prone to speak his mind, as I said, and he wasn't going to stand for it. He was going to, and he was called to testify before the U.S. Congress, but his superiors in Canada forbade him to go and testify. So what he did was took vacation time, traveled on his own dollar, and testified anyway.
Bit of a maybe ignorant question. You mentioned Excel is like kind of phasing out from coal towards natural gas. Is that better, worse, or just like on the same playing field, just different?
It's marginally better. It's a stopgap measure. In the long run, we need to move away from using fossil fuels altogether to deal with climate change.
Can you relate some events that this is so cyclic? You look at the intervals.
Oh, this.
Yeah. Why does it get so low and then all of a sudden it goes very sharply back up again? What's going on?
You're looking at ice ages.
Yeah.
So when there's an ice age, the carbon dioxide concentration in the atmosphere is going to increase. And then the planet warms. The plants grow, they suck up that carbon dioxide, and the carbon dioxide concentration falls. So it's the cycle of what you're seeing here is the cycle of ice ages over geologic history.
It's so regular.
Yeah. Well, we're messing with that cycle.
So are there ways to take the carbon dioxide out of the atmosphere? You mentioned that as a possible solution.
Yes, there are ways, and there are some pilot plants that are doing that, but it is, I would say at this point in time, experimental. It's not a technology that is ready to be geared up to the level that might be necessary. the first step I think we have to take is to stop emitting.
Looks like everybody bought electric cars at the same time.
Well, electric cars are hot. The car companies are ramping up production of electric cars. I mean, they're not without their problems either. But you know, lithium batteries and extraction of ores and all that, there are, you know, any technology applied at the levels that we do is going to have side effects.
There's no other questions. I do want to just thank everyone again for joining us tonight. We really appreciate it. And I'll be sending out a recording of tonight's program and a copy of the PowerPoint, so that way you guys can engage with some of those links that Gregory was sharing with us earlier. So thank you again to everyone for joining us, and we hope to see you at some of our future events. We're going to talk about the historic landscape of Mayowood, the Civilian Conservation Corps, and a wide variety of different topics. So we hope that you continue to join us in the future. Thank you so much for everyone for joining us, and have a good night.
Thank you.
Thank you.
Okay. Coming off the air. Okay, I got a question. I didn't want to bring it up because